We've got a fun presentation tonight from Glen and Mal on the Microbee and the historic computers in the late 70s, early 80s. We'll hear all about them. They were designed and made here in Sydney. And historical personal computers as opposed to historical computers. You've got to go back a bit further to the history of computers themselves. And I might do that at a later date. But tonight we're going to hear about the history of the personal computer from Malcolm and Glen. Thank you guys. Take it away.
So yes, thank you for the intro. As I've mentioned in the email, and which also raised a bit of chatter on the email reflector, old computers, and a few people reminiscing in the emails, and I'm sure there'll be a few more tonight as well later in the evening. Yes, thanks. If we could hold the questions till the end, otherwise the YouTube gets a little bit disjointed. Mal, VK2TMF.
Glen, no fixed licence.
VK2 soon.
Yeah.
So I'm going to talk a little bit about getting old computers going again. I guess it applies to anything old, usually digital. None of us are any strangers to ratting or getting old stuff from the junk table or Wyong or wherever to fix up and get going, or storing them for a rainy day. So in recent years I've started collecting 80s home computers. I've got a TRS-80, an Apple IIc, which I'd like to thank Tim for. He started this. I blame you. Apple II Plus clone, an IBM XT clone. You might have seen my email looking for an XT keyboard a while ago. I did find one on eBay eventually. A couple of Commodore 64s and Tandy colour computers, TRS-80s. So I'm trying to... the reason I chose those computers is they're not too big. They can keep them in the attic in a box and none of them take up too much space. My first computer was a Apple II. I was very privileged. The first computer I messed with was a ZX81 and I thought, wow, this is amazing. Anyway, I'm going to talk a little bit about resurrecting old stuff that hasn't worked for a long time. And followed up by Glen here, who's kindly brought in some of his collection, which may or may not have been turned on in recent years. So we'll go through the process with one of them. Don't know how far we're going to get. See if we can get a blinking cursor or not. Obviously here it's a little bit hard because I don't have my drawer full of TTL chips with me and things like that, or RAM to start messing with things. Anyway, without further ado, this is my Microbee. That's how I got it, from Trash and Treasure. It was not working when I got it. It had a whole bunch of mods on it, which I undid and got it back to what it was supposed to be. But it does work. At least it did last time I turned it on. So might have a mess with that later. So the first thing I'll do when I get a computer is just a visual check. See if it's complete. See if there's chips missing. See if there's corrosion. None of these computers, thankfully, are old enough to have, or new enough, I should say, to have batteries that leak. So unlike, what is it, I guess 80 or 386 onward, had batteries which were notorious for leaking and corroding circuit boards. So yeah, first part is a visual. Identify it, find out what it is. Then I will usually spend quite a few hours in an evening looking for manuals, looking for schematics, looking for support groups, forums, to find out about the computer. In this case, and I still don't have one actually, thankfully Glen did, is a cable for the power. This one's a little bit weird. It carries power, video, cassette in and out, all on the same connector. So it's only a DIN 5 pin, and if I weren't so lazy I would have made one already, but just have it. Expansion connectors, what kind of RAM they have, what kind of processor they have, how the keyboard might work, importantly, what the power supply requirements are. One of the things before you start putting power on things is to find out what goes wrong with them or what's common. In the case of the Commodore 64s, that power supplies are notorious. The little 5-volt regulator, they're only rated at 1 amp and they probably run 1 and a bit amps to power everything. So they tend to overheat, go short circuit and put 12 volts into the 5-volt line. So my Commodores have both had their 5-volt regulators replaced, and I just don't leave them on for a long time anyway. What is neat about 5-volt regulators now is you can get little switch mode regulators in the same form factor as the usual 3-pin regulator with a heatsink. What's the package size?
7805.
7805. The package size escapes me.
TO220.
TO220.
TO3.
TO220. That's what I was looking for. In the case of this one I believe was one of the early kit set models. This one did have a TO3 regulator in it, which was just a mess. The way it had been the circuit board had been modified and messed around and it overheated, you could tell. So I removed it completely and replaced it with a little 12 volt to 5 volt switch mode power supply. I'm more interested in getting things going. I'll try and keep things original if I can. So if I was hell bent on keeping it original, I would have replaced the TO3, but then you've got something that still overheats and might fail in the future. The main bulk storage capacitor here for the input had also failed and leaked a little bit, but it hadn't damaged anything, thankfully. So that's been replaced as well. In the case of so where was I? Power supplies. Yeah, check the power supply first. So in the case of my IBM and the Commodores and everything else, you don't plug it in until you know the power supply is safe. In some computers, the TRS-80, there's a transformer in there, and it goes straight onto the main board on a connector. So all you can really do is unplug the transformer from the main board, just check that the AC looks sensible, and then see what happens when you plug it back in again. Open it, visually clean it. Sometimes they're just full of dust and awful, so it's best to get them clean before you start rather than when you're starting to try and mess around with it. Fuses, see if there's anything blowing. One of my TRS-80s, the fuse was not blowing, but the holder was open circuit. So I thought, fantastic, this looks great, it's going to go first time. But not so quickly. Didn't take much to fix, but it's one to watch. The next thing we do is you might want to remove expensive and hard to find chips if they're socketed. In the case of these, I think I popped all the RAM out, popped the CPU out, popped the EEPROMs out. So obviously it has no chance of running, but when you turn it on, you're not going to risk blowing chips that you just cannot replace anymore. Thankfully, with the internet, code for EEPROMs is fairly readily available for old computers. There's quite a following in various archives with all sorts of software and hardware and ROM information as well. One thing that's super helpful with the ROMs is the Microchip make EEPROMs that are pin compatible with EEPROMs. So with your trusty EEPROM programmer, you can program the EEPROMs so you're able to flash the code instantly without having to worry about using an EEPROM eraser and it taking half an hour and too long to erase ROMs. I do use EEPROMs from time to time. For the eraser, I use a little toothbrush sanitizer thing that I got off eBay or AliExpress or something. It's just a little, I should have brought it, little plastic enclosure that's intended to have toothbrushes put in it. and the light inside emits the UV you're not supposed to look at. I can't remember which one it is. C. And it put the EEPROMs upside down, and it erases them over about half an hour, which is fine. So yeah, remove any chips. Check the power supply, check the voltage. Then when you plug it in, look for anything that's getting hot that shouldn't be. In the case of one of my Commodores, the RAM chips were too hot to touch for whatever reason. So thankfully the UK actually has quite a good retro computer market or shops available. So I was able to get some replacements fairly economically, and the postage from the UK, as you probably know, is really reasonable. Getting stuff from the US is ridiculous for $50 postage for a $5 thing. So yeah, keep an eye out on UK websites if you're looking for stuff, whether it be radio related as well. Then check the 5 volts. Check the 5 volts and make sure that it's present. What else have I got? And then turn it off. If you're happy, plug all your chips back in, turn it on and cross your fingers and toes. And then, well, depending on what part of fixing stuff you like, that might be where the fun part starts, to try and repair things. So that's where we come into some of the tools I use. Obviously, a multimeter is the first thing you want to be having, so you can check your 5 volts, check levels, check for ripple on the power supply. The storage caps or the smoothing caps on the outputs of the bridge rectifiers you might want to look at. Check if they're swollen or not, or gone low resistance. I do have an ESR meter somewhere at home too, so I can so you can check if the capacitors are any good. Glenn, on his disk drives here, what did you have to replace?
In the power supply, the reefer capacitors let out the magic smoke a couple of years ago when I turned them on. Probably the most recent time was maybe 5 years ago, and there was a big poof, and they splattered their stuff everywhere. Replacements easy to come by, like from JK or somewhere, so that was no big deal. Just was quite a bit unexpected and loud and smelly.
Spectacular.
Yeah.
Some of the other diagnostic tools I use, well, the EEPROM programmer. This EEPROM programmer is good in that. You might get blinded, Glenn. See, here you go. A lot of modern EEPROM programmers, good, I think it's going to work, are able, we'll wait patiently.
The valve projector warms up.
There we go. Are also able to test logic chips. And this one in particular can also identify them. So if I get one of these TTL chips, I can make it sit in the right spot. Make sure I put it in the right way around. So this programmer is quite clever in that what I can do, you can see here how to orient the chip. You've got a whole list on the left-hand side here that you can choose from, or you just go auto find, and it figures out where the power is connected, and it also goes through a whole raft of tests, checking all possible inputs and outputs for its library of chips. And it's told me that it's either a 7437 or a 74137 or a 74138. So that's a 3 to 8 address decoder. So that takes the hard work out of testing logic devices. It really does. On my Apple II, I had to go through all of the chips, and I still didn't find what was wrong. But it didn't take too long just by doing it this way. If you do, it's also good if you can't read the numbers on the chips. You get some idea of what it is and what it's supposed to be doing. So yeah, it's a fantastic tool. It really is. So if you ever have the need, grab one of these. The model you can come and have a look at later. But yeah, highly recommended. What else do I use? Old logic probe. Hands up who had one of these back in the day. Just about everyone. Now Tim's got a really cool test instrument which I haven't managed to borrow yet, and that is a current probe. Correct me if I'm wrong, Tim, but I believe it might have is it a Hall effect sensor in the tip?
I believe so, yeah.
So you can hold it next to the trace. Say you've got a stuck data line and you don't know which chip is causing the problem, and you've got a dozen chips on the data bus. How do you know which one's drawing all the current and pulling the line down without desoldering all of the chips, by which time you would have destroyed the board and the whole thing becomes a waste of time. So with that, you can touch the probe on each of the, in this case, let's say data pins, until you find the leg of which chip is drawing the too much current, and that'll either be the driver or an input to one of the chips that's stuck high or low and drawing too much current. Once you know what the chip is, you know whether it's, which end's which. So EEPROM programmer, diagnostic ROMs. No, we don't need that on anymore. Where's the light switch for that?
Oh, sorry, as soon as I want to stand up. Oh, sorry.
The other one.
No, that's good. That's good. You can have them both if you want.
Okay, so where was I? Next thing is diagnostic ROMs. Some very clever enthusiasts have made diagnostic ROMs for various computers. This one's for a TRS-80 in colour computer. So it emulates the little cartridge that you could buy with your games and programs on, but they've coded a diagnostic ROM. So it allows you to boot the computer without having a cassette interface, without having a disk interface, assuming, of course, that the computer you're working with has a cartridge slot, and and test the screen, the RAM, EEPROM, I/O, joysticks, whatever you need to. Often these are called a dead test ROM, at least from the Apple world, where you pull out the highest memory ROM, shove the dead test ROM in, and it'll just cycle through memory, screen, so at least gives you a start to figure out what's wrong. Another thing that is super useful is a no-op board. So, as I'm sure you all know, CPUs have assembly instructions, one of which is no-op, which means no operation. So what you can do, and I did this on my Apple, is I made a little, just hardwired an IC socket and to plug in to a ROM position. And what that does is, on the data bus, puts the correct opcode for no op on the data bus. You turn the computer on and it'll just cycle the memory continually from, in the case of the Apple, 64K. And it just continuously loops. So that allows you to see what the data bus is doing. So on the least significant bit 0 of the address line, you'll get a high frequency square wave if everything's going well. Address 1, half the frequency again, half all the way until you get to A15, where you have a relatively low frequency. What that really helped me to do is to find a real problem I had with some address decoding, where I could see that the computer wasn't booting, but I couldn't tell why. I didn't know how far through the boot process it was getting. Anyway, with this one, the ROMs were being seemingly addressed correctly, but it would just die at the beginning of the boot process with random or with particular character on the screen. So the video was working, but what that allowed me to do is to probe all of the address decoders, see where the particular frequency for the address bus was getting to, and ultimately pinned it down to a logic gate, which wasn't on the schematics. Being a clone, there was just a slight variation on this part of the circuit. I found some discussion on it on this particular chip, and somebody had a really terrible hand-drawn schematic of how this chip integrates into the Apple II. It's the only part of the schematic that's really different. Well, it's the most significant part anyway. Other minor variations that I found. So, logic probe, an oscilloscope is always handy if you've got one, especially for checking clocks. Again, with my Apple, when I first got it, the board didn't work at all. And one of the clock divider logic chips was dead. So that got that going. This Apple's had way too much time spent on it. And that is about the end of my chatter until we start trying to get something to work. So we'll try and go through the process that I described, knowing that Glenn has done a little bit of the homework in advance. Maybe before we get onto the practical side, where people will probably drift off a little bit. Do you have any questions at all now? Go ahead, Tim.
Yes. With the your logic analyzer chip tester.
Yeah. Chip tester.
Device.
Yep. EEPROM programmer.
Does it test each gate? So if it comes up with and says this is a 7.4 whatever, does that infer that the chip is working, or could there still be issues with it?
Ooh, if I click on one, so let's do that. Oh, that was a 138, wasn't it? 74138. So how many combinations are there on that? There'll be 8 and a few with enabled pins. So in that instance, not without looking at it closely, I would say yes, it does. But I do know that some of the similar devices just test enough to verify that the device is what it is. I haven't figured out how, but you can also import or create and import logic tests. So if you had a PLA, for example, that you knew what the expected outputs were for a given input, you could create custom devices.
When I had a Microbee, I can't remember why I did it, but I pulled the whole thing apart and painted the inside plastic shell with nickel-loaded paint to make an RF shell, I guess. I can't remember whether it was because it was causing problems or it was subject to interference from other things. But it was quite a process.
I don't know, I couldn't speak to it.
There was a lot of hobby discussion and things around this in the day, like in Electronics Australia and ETI, where they talked about all sorts of things. And I think that was due to RF emissions from the computer, or high frequency emissions from the computer.
Phil?
Yes, I was just wondering, apart from electrolytics associated with the power supply, are there any other electrolytics around boards that you see that you might routinely replace?
Usually not. There's often tantalums, because that's the generation of tantalum capacitors. You soon know after you turn the 5 volts on if there's a problem. They just snap, crackle and pop, explode. Hopefully they don't. I've had them go short circuit before, and they're a pain to find. Oh, they're not particularly reliable. Tantalums are a pain.
They don't leak in the same way, though.
Yeah. They'll usually pop often. As long as your power supply is strong enough, they'll explode and go open circuit, and you'll hear the crack. You don't know what it was, and you just keep going. It still works.
Tantalums were expensive. They tended to use
ones are only just rated for the voltage. If you're replacing tantalums, you can replace them with other tantalums, but put them in at double the operating voltage, not at 5% more, 10% more, and they're reliable forever.
Yeah, that's good advice.
So that's advice from Ian Schwab, who repairs this stuff and has done for many years. My question was, how do you look at the power supply report? Scope
or just your meter on AC.
Would you look at it before you put the tube back in or after as well? Before you put the tube back in?
I'm lazy, usually not after. If there's something not working, you'll go back and look at it. Richard?
I imagine you've amassed a huge library of fascinating information that you've got right at your fingertips when you're looking at a particular thing. How have you done it?
I just have folders on my computer. I don't tend to keep paper manuals. I get them if they come with them, and I hold on to them, but I don't purposely go out looking for manuals. Mind you, in saying that, I just got a haul of about a dozen Apple II manuals a while ago, but they're going on eBay.
And do you find it easy enough to be able to source digital manuals or scan copies of them off the internet?
There's enough enthusiasts around that just about every manual I've wanted has been somehow available. What's a pain is the clone manuals for clones, whether it be for my XT, and particularly this Apple. I don't have a proper manual for that board, and I never will have. But it's close enough that the original manuals are good enough, except for this 7408 chip that was not on the schematic, which was also dead. But unfortunately, a lot of them are not OCR'd, so yeah, they're quite substantial manuals, and you spend a lot of time paging up and down. I guess with AI, I can point AI at it, and it might OCR them, and I can search them and ask AI questions about them, but I haven't got that far.
It's a bit like using Trove. The quality of the image is not always really good for doing OCR on.
Absolutely.
And that's the problem. You need that manual verification sort of step.
Yeah. And the schematics are sometimes pretty woeful, where they've been scanned and the paper's ripply, and the creases don't line up.
It's in a book and it curves into the middle. You've got to sort of flatten it under a photocopier.
There's a really good program called CamScan, which I subscribe to. I get work to subscribe to it for me, really. But it can take that bend out of the photos. It's really good. A friend of mine that does ancient book archival uses it for shorts, scanning little things. The guy also has one of those really expensive scanners for books. But if he likes that software, it's got to be good enough for me. Anyone else? No? Okay, Glenn, let's let the magic blue smoke out.
No, hopefully not. It stays in.
Not quite sure how to do this. We don't have a downward-facing camera.
No.
But we'll just, I guess, talk and potter and see where we end up.
Okay.
So, here's our first candidate. What really sucks when you get the computer first, often the warranty sticker is over one of the screw holes, and it just seems sacrilegious to destroy the warranty sticker. Might need it. Yeah.
So with the Microbees, they have a main board which covers the whole base, includes the keyboard attached to that board, and that's generic across all the different models. And then there's a daughter board on the top, and that has all the memory and the EEPROMs and so forth. And in the models with hard disks, it has the disk controller as part of that board. So by swapping that board, it's easy to do upgrades, and that was a thing that was big in the day, And that's what I did. I bought this computer in 1982. It was a cassette tape model, and after a couple of years, I upgraded that to sent it back, and it came back with a couple of floppy drives with it. And essentially, it was the same base board, couple of engineering updates to it, so a few jumpers added, and a new daughter board on top, which had a different amount of memory and a floppy disk controller.
Oh, it even has 1982 on there.
Yeah, all mine have. Oh, okay.
What's this one got? Also 1982.
I think that's when the case is made. But that one looks like the handmade kit because it's got every chip socketed, whereas these ones don't have that.
Yeah, the early Microbees, they first came out as a kit before they were manufactured. Somebody offered to swap me that one for one that was complete. I never took them up on it. I'll let you do that actually. So I haven't got one with a lid. I don't know how the lid comes off.
Oh, okay. You take a look.
Oh, there you go.
That bit comes off, and then that bit comes off.
Well, that's a hell of a lot cleaner than mine.
So if you look at Malcolm's one, hold yours up. You can see the difference between the two daughter boards. Entirely different. So Malcolm's has got 16 2 kilobyte CMOS RAM chips. That's what they are. They're 6116s.
Yes, they are.
Yeah, I know that. Whereas this one has got 8, and I guess they're 8Ks to make 64K of memory. And there's another bank there. There was another model above this with 128K of memory. And so that was essentially this same controller, extra chips in there, and there's a magic PLA there.
Right.
And so the pink code is for 64K. So you can't just put the chips in, you've got to have the right PLA there to give you the 128K. There's a little bit of dust across the back there.
I didn't bring my paintbrush.
Not too bad.
Righto. Power supply.
Yeah, just plug that
Now,
in.
what I didn't have is the pinouts.
Oh.
Shall we measure it before we plug it in?
Yeah, you can do that.
Do as I say, not as I do.
You want to know what the pins are?
Yeah. You got
So back in the day, I was a member of the Microbee user group, Sydney Microbee user group. We used to meet at North Sydney, and then we moved to Strathfield High School. And that was a great place. You'd take your computer along, and we'd all set them up there, and we'd all madly swap discs, and people would bring in manuals. And so I have things, Microbee technical manual, circuit diagrams, all sorts of words of wisdom photocopied from somewhere. And the other book I've brought along to, I have a whole, about a metre of bookshelf of Microbee stuff, a hardware notebook which written by the engineering manager at Microbee, and all sorts of details about the design of the system, which is, if you're nerdy, it's great reading, but for this kind of level of repair and stuff, really useful because it's got all that nitty-gritty kind of detail. A lot more than just a circuit diagram, it's got an explanation of how it works. So you wanted to see the power
I'm not finding the pinouts quickly.
Oh, let's just have a quick look through here. So for example, some of the top of the engineering changes, so circuit changes, upgrading baseboard, converting a black and white TV set to a monitor, network EPROMs, modification for as an experimenter's board. So there's one of these that had all sorts of extra buses and things on it that you could hook stuff up to. All sorts of modification to the floppy disk controller card. That might be a useful thing to do. We want the power supply. This is what happens when we just do quick main search.
There we go.
Gee.
Google's your friend. Google image search is even better, just for finding things quickly. Interesting, Microbee technology still exists.
You've reformed a couple of years ago. There's a Facebook page. They've got a shop front in Melbourne. They have a bunch of
They sell
new Microbees that
Increment.net has the pin out for you.
have
this one here.
new Microbees that function like the old ones, but use things like SD cards and GoTech and stuff for storage rather than floppy disk, which is kind of neat. That's what I would love to have, is ditch this floppy controller and just have an SD card in there. I'd have 100 floppy disks worth on an SD card.
Sorry, everyone, it's going to get a little bit boring just as we fiddle about. There we go. Now, holding these are not
It's only got
shorting them
two
out
things
at the
wired
same-
to it, so if you short something, it probably won't do anything too bad.
So pin 3 and pin 2. One end and the middle one.
Well, that's switched on. Got a red light there, yep.
Not sure which end pin 3 is, but we'll work it out.
It should be close to 12 volts.
Come on.
There we go.
11.36.
Yep, that's good enough.
So we'll check the AC as well. How do I switch that to AC?
So the power is nominal 12 volts. There's a regulator on the mother that cuts it down to 5 volts. So anything more than about 7 or 8 is going to be. So this is a switch mode power supply, so that should be pretty
okay.
ripple free.
Good. So that's that. Did you want us to go to the trouble of pulling the chips, or
Nah.
just leave it? Okay.
All right, you can plug it in. I'll just turn that off.
So we don't have your board on top of here yet, so it's not going to do much without that.
Just got to make sure to get not be out by one with the pins.
The enthusiast community for different kinds of computers is quite amazing. I have a board for my XT, which is not super expensive, but it has on board a ESP32, and that's connected up to the address and data bus. It can emulate a sound blaster. It outputs. I'm trying to not mix up my cards. I've got an SD card in the back, so it emulates a floppy disk and a hard disk. So if you don't have some of the old hardware, you can still get things going. The board for my Apple has a similar board, but with a Raspberry Pi microcontroller, the 4020 or whatever it's called, not the Linuxy thing. With a similar arrangement with the address and data buses decoded, and it has a HDMI output by bit bashing HDMI. It reads the address memory, the video memory from the bus as it's addressed, and creates the image and outputs it as HDMI. Actually, that's what I had up here the other week.
Okay, we're a smoke test.
Okay. Let's see what
I
happens.
won't lean over because I don't want to blow up in my face.
Sorry. What have we got? Anything? Nothing?
Yes, a little white cursor.
Yes.
One white cursor. And that's your lot.
And we've got a red light on the floppy drive.
Okay.
What we should be able to do is, if there's some life there, we should be able to get to the monitor, which we can't. So I suspect that this is... Oh, there's something.
So you won't be able to see that, but there's a white dot, white character position on the screen, and for a moment there it came up with a whole lot of, I don't know if it was at symbols
It's
or
just gibberish, yeah.
some gibberish on the screen. So this computer needs a bit more attention.
Yep.
This is a composite video monitor,
Yes.
Yes.
so you still need to find one of those.
Find one. Yes,
Well,
they're hard to find now.
Yeah.
I do collect them.
I've got two Microbee monitors, or two monitors that I used to use with my Microbee that are, one's dead and one's got no vertical height at all. You know, the horizontal green line.
Yeah.
So so if you do have any old like 16-inch colour TVs that still have analog inputs, or even better, having composite inputs, they go for between about $100 and $200 on eBay now.
I got one for nothing off Northern Beaches freebies.
Right.
A little Sony Bravura, about that size.
Mm-hmm. So it's weird, but that old tech is becoming more collectible. Now I need to find somewhere where to hook up my logic probe. what we'll do is, not having a schematic immediately at hand, because I would usually... Here's one you prepared earlier.
Here's one I prepared earlier. Let me try and find the right
We'll see if we can
schematic.
find some address and data lines to probe, and maybe a clock.
How about pictures of waveforms?
Fantastic.
Here we go,
So I'm
Malcolm.
just going to find a 5 volts that I can put the logic probe on.
Okay.
And your 5 volt rail is 5.08, which is pretty good.
So these are all on, there's a whole bunch of test points that you can use. These are all on the main board.
It's very good.
What I've seen in the past is an adapter that allows you to sort of mount that daughter board about this far above the other one, so you can get in underneath it to things.
It's very good that the Microbee is well documented.
Yeah. So there's a whole bunch of test points there with photographs of the oscilloscope waveforms.
Okay, so data bus and address bus. Where can we find that? Probably
Well,
on
there's
the
all the
EEPROM.
memory chips, so somewhere along those.
Not knowing the pinouts.
Okay, let me just...
I've started collecting. Well, I don't need any more. At the last Trash and Treasure, I got some early 90s logic TTL books. You know how you used to get binders on logic chips and RAM and some processors and things. So that's been quite useful actually, because even some of the chips that I want to find data on, you can't really find on the internet. So having some logic books is fantastic. Thrown them out in the past, but now I collect them again. I'm just going to start going for it on this EEPROM. High, low, oscillating, oscillating, oscillating. So there's some bus activity. This will be a job for Tim's current probe one day.
Very great stuff.
Yeah,
So what we know now is that the clock is working and the bus seems to be working without my looking out the... In real life I'd look out the pinouts for a... whatever that is. 482764 2764 EEPROM, and find out which of the chip selects and which are all of the bus connections, and look for activity
I could have,
based on the schematic. Anyway, this one's not very happy. Let's see what the ripple's like on the power supply, given that the capacitor's looking a bit worse for wear.
I'd possibly argue you probably just remove that and just rely on the output from the switch mode power supply to be good enough.
So no ripple to speak of, so that's good. Anyway, that's as far as we'll get with this one tonight, I think.
Oh, okay.
So on the 2764, from pin 1, you've got a power supply pin.
Yep.
The next 13 on that side are address pins, followed by 4 data pins. So the 4 data pins are at the end opposite the pin 1, pin 28, except for the ground pin, which is on the pin 1 side at the end.
It's a 28 pin device. 28 is high, 27 is high, 6 is varying, the rest are varying. Anyway, you get the idea. I'm sure you've all messed with logic, circuit logic, troubleshooting logic if you've ever been in electronics in your career, which I think most of you have.
More than I have.
Okay, well that's the first look at this one. Let's turn off and we'll
Try
get the other one out. Actually, what I didn't check for was hot chips,
Oh, okay.
but the RAM feels all right. What's a bit of a pain with some of the older RAM chips is they need a minus 12 volts, which means you can't test them so easily. Or minus 5 volts, I forget.
So I was just thinking before, Malcolm was saying how he collects old computers. I just never throw them out. I've got a whole bunch of other various ones that I picked up from work, like enterprise sort of desktops and.
So needless to say, when you're all downsizing, think of me when you're getting rid of your old shit.
So you can see that motherboard's different to this one.
Very. Wow. This one's called BootNet.
So you look at the thing, that's a 1983 model, and I think this one is a 1985 model.
Okay, what's this one?
The chip will have a date code on them too.
Sorry?
The chips will have a date code on them.
Yeah.
Yes. So it's not...
Often they'll have a
81.
Often they'll have a 2-digit week of the year followed by a 2-digit year.
Yeah, except for most of them. On this particular case. Unfortunately, sometimes the chips have batch numbers, which doesn't help you. 1981, 36th week on a couple of the chips.
Yeah. Okay, so this is exactly the same.
Oh, really? Could it be the disk controller?
Without the disk controller, it doesn't.
Hang on, turn it off first.
No. That literally just goes to the 2 floppy disks. There's no other.
There's no electronics in the middle.
Only the circuit board on the drive. Okay. Oh, I don't want to break the connector. It's the same.
Same problem. Well, let's see if mine still works. Then we can stop. Then we can swap the top boards over and see if it's the bottom board or the top board.
Yeah, as long as your bottom board's not too old.
Oh, they're not compatible?
There were engineering
do
changes made over the years to work with things like.
Righto, turn it on. No activity. Oh, there's a power switch somewhere, isn't there?
No? Oh, have you got a power switch? No, I don't think so.
No, not this one. No. Oh well, that's very disappointing. Used to work. It is on. Oh, hang on. I'll check some pins.
Yeah, we've got a red light there. So a power light.
Nothing smoking.
Measure over here anywhere you're on this capacitor or something.
No, just go on a logic chip. Yeah, 4.9 volts. Well, it used to work. Such is life with old crap.
Yeah.
Righto. Any questions? We're going on as far as we can tonight, I think. A bit disappointing not to get a flashing cursor, but anyway, such is life.
Here I was hoping to see Mal with the soldering iron and the logic analyzer and pulling all the things off the board and going, oh, we need a new one of these, and whipping one out of his kit.
No, that just...
Now, what gives you the biggest buzz? Is it actually finding something that you can tackle, or is it actually getting that first flashing cursor after you've worked out?
Look, the flashing cursor is certainly a really high point, because you go, oh man, I haven't wasted my time and money. The process of, look, it's all, I enjoy it all. Even the most tedious part is finding stuff, because I limit myself in budget. If you have ever tried looking for this old stuff on eBay or Facebook Marketplace, it's sometimes not very cheap, multiple hundreds of dollars, even $1,000 for a really good condition Apple IIe Euro Plus. I limit myself to $100 for every computer. So that puts so I've got to be really quick on Marketplace if I'm going to find something. Or a bit more if they've got loads of accessories or something. The first power, pulling it apart, seeing how it works. The research I do find interesting. Just learning, looking at the schematics, seeing how it works, seeing how the power supply works, seeing what makes it tick. And then trying to figure out how can I get this to work. In the case of the Microbees, having the shared connector between power and video, oh man, you've got to make a cable or find a cable. The other things are easier. Sometimes they're much easier. Finding software is always interesting, and how you bootstrap something if you don't have any disks for it. In the case of the Apple II, it's really quite clever. Somebody's written some software called ADT Pro. So you've got your Apple II, you're lucky enough to have a disk drive, you found some disks on eBay, used disks, and that you hope work. But how do you get DOS onto it? How do you get it to boot? How do you then get your games and things onto that disk? There's a few approaches. One is using that boot card that I mentioned about, where you can put an SD card in and get to load up disk images. That's it's very cool, but kind of cheating. But the software called ADT Pro, you can load over the serial port on an Apple II if you have a serial card. That's another dilemma, trying to find one that works. But you can put a crossover cable between the serial card on the Apple II, on your PC, run the software on your PC, type some commands on the Apple II, and it will start taking input over the serial port. So then when you press go, you get a whole lot of assembler being programmed as if you were typing it into the Apple, which will then eventually run the software for creating disk images, which you then load over the serial port. Even if you don't have a disk drive and you don't have a serial port, what do you do? Or if you just don't have a serial port because you can't use it, then you can use the cassette interface with your phone and an audio cable. If you've got a phone with a headphone socket, you can play back cassette images from your phone into the computer to then load up the software to transfer images and create disks. It's really mad how clever some people have been to bootstrap a computer when you have no media. It's really cool.
What sort of data rate do you get reading off a cassette tape?
Oh, what is it? It's about 300 or thereabouts.
300 or 1200. So the Microbee could do a 1200 baud bits a second. It's slow, but you're only loading programs that are tens of kilobytes in size, so it's not too bad. Couple of minutes.
A few minutes, yeah.
It's not like you're trying to load a 10 megabyte file or something.
Well, thank you, everybody. Hope you enjoyed tonight. It was a bit of a ramble. Something I enjoy. I hope you got something out of it. Good. Why doesn't this work?
I don't know.
Is this off?
It's a Microbee, and one day the logo fell off, and I found a flavour in a garage.
All they are is 12 volt 1 amp
Yes.
power brick. So
Yeah.
you want the real thing.
I want the real thing.
Look.
Yeah.
Otherwise, you
A genuine imitation.